This is Year 2 Pure, Chapter 1, and the last section in the chapter, and this is on algebraic division. Now, we know that with numbers or with fractions, you can get an improper fraction. Okay, so that's an improper fraction when we deal with numbers. Now, you can get an improper fraction, an algebraic fraction. Now, you need to know something about when we have a polynomial. That means, like, you might have something like x cubed plus 2x squared minus x plus 7. That's a polynomial. Something called the degree of the polynomial. Now, the degree of the polynomial is the value of the highest power. Okay, so this polynomial has degree 3 because the highest power in the polynomial is 3. So we say that it's got a degree 3. Okay, here's another algebraic expression. So let's say I had 2x squared plus 5. Okay, so this at the bottom, its degree is 2. Now, we can get an algebraic improper fraction when we have an algebraic fraction and the degree at the top is the same or higher than the degree at the bottom. Okay, so here we've got an algebraic fraction and the degree at the top is 3. It's higher than the degree at the bottom. Even if the degree at the top was the same as the bottom, there are some values of x for which the fraction can be improper. Okay, so if the top or the numerator of an algebraic fraction has a degree greater than or equal to the degree of the bottom, okay, let's give its bottom proper name, the denominator, we say the fraction is improper. Now, you need to watch out for these because you may not always spot that it's an improper fraction. So, for example, x squared plus 2x over 5x squared minus 3, that's an improper fraction. Even though you think, well, how can it be improper? Well, let's maybe make it look like it's really improper. Let's stick, no, let's leave it like it is. You might think, well, the top is smaller than the bottom. There may be some values of x for which the top is bigger than the bottom. But the rule says, even if the degree of the top is the same as the bottom, it's improper. And if we have an improper fraction, there's some steps we need to take. The first thing we need to do is we need to do long division. And we want to do long division to get at the quotient. Now, what's the quotient? Right. When we do a long division, let's just draw what a long division might look like. We've got some stuff down here and we're dividing it by some stuff here. You're going to end up with some stuff at the top. I'm using the word stuff a lot. Whatever we have written up there, that is called the quotient. This bit here, what we're dividing by, that is called the divisor. Let's go for a thinner pen. So, divisor. And then you may have some stuff left over down here. and whatever stuff you have left over down here, that's the remainder. And when we do these questions, we're going to do partial fractions on the quotient. We just do partial fractions on the quotient, and then our answer is going to be partial fractions done on the quotient plus the remainder over the divisor. Okay, you'll see that in a moment. So we do long division to get at the quotient. We do partial fractions on the quotient, and our final answer is going to be those partial fractions plus the remainder, what's down here, over the divisor. You'll see that in a moment. Okay, so this one, we can see the form that they want us to give the answer in. You can see it here. And actually, we should just be able to get this answer by straight long division. We could use the fact that the function is equal to the quotient times the divisor, add the remainder. We can do it that way. But personally, I just prefer doing long division. And this bit here is going to be the quotient. So that's the bit that's at the top when we do long division. And that is going to be whatever the remainder is. So now we're going to do long division, because it is a division, isn't it? X minus 3. And that's the divisor. And we're dividing x cubed plus x squared. Now we need to write plus 0x minus 7. Okay, so let's have a go at this. Right, x is into x cubed, goes x squared, multiply x times x squared, x squared times minus 3, subtract, that goes x squared plus 3x, 4x squared plus 0x, x is into 4x squared, 4x multiply 4x squared minus 12x, subtract. So it's just this algorithm, series of steps we just repeat over and over again. So that will leave us with 12x, bring down the 7, x's into 12x go 12, then we multiply 12x minus 36 and that will give us, when we subtract, so that's like 7 minus 36, so 7 plus 36, which is leave us 29. Right, so 29 is our remainder. The quotient is this, x squared plus 4x plus 12 plus the remainder is 29 over x minus 3. So we found a is 1, b is 4, c is 12, d is 29. Next one. So here, all we're going to do first on this one is we'll start by dividing both sides by x minus 3. So it's in a form that we can deal with. So we've got x cubed plus x squared minus 7 over x minus 3 is equivalent to ax squared plus bx plus c plus d over x minus 3. And then it pretty much becomes exactly the same as the previous one we did. Yeah, so we can start by doing it that way. Okay, so we're dividing by x minus 3, x squared cubed plus x squared plus 0x minus 7. X's into that go x squared, multiply to give us x cubed minus 3x squared, subtract 4x squared. This looks familiar. I think this is the same as the last one. Could be wrong. X is into that 4x, multiply 4x squared minus 12x. I think it is the same as the last one. You basically multiplied, didn't we? Or divided by x minus 3 to make it the same. Okay, yeah, it's the same. Plus 12, 12x minus 36. Okay, 29. It's the same as the last one, but you can see we started by dividing by x minus 3. I did say there is another way of doing it, and that's realizing that the function that you have, and it's sort of written in this way, is equivalent to the quotient multiplied by the divisor plus the remainder. And you can set up and do, when you compare coefficients, you can expand the brackets, compare coefficients, and you can do it that way. Yeah, that's another way of doing it. So you can expand the brackets out of this here. Yeah, expand the brackets out and then compare the coefficients. Look at what's in front of x cubed on this side, 1. Look at what's in front of x cubed on this side, which I think would be a. Yeah. Then compare the coefficients of the x squared terms. You've got 1 here, and then with the brackets expanded, what have you got in front of x squared over here? Yeah, I think it'd be something like minus 3a plus b, something like that. When you compare the x term, well, you've got 0 there, whatever's in front of the x term here also has to be 0 once it's expanded. And then the number is going to be negative 7. Over this side, in front of the numbers, you'd get minus 3c plus d. That's where the number comes in. Yeah, so you can actually expand the brackets. Let's write that down. The alternative method is to expand brackets, then compare coefficients. Yeah, so that's an alternative way of doing it. Right, next one here. It's all pretty much the same type of thing. It shows us what the form it should be given in. There's our quotient. We're going to have a remainder here, so we'll do long division. Okay, so if I'm going to do long division, or if I was going to do it the other way by comparing coefficients, what I would do, I would set the question, or I would set f of x equal to this, then multiply both sides by the divisor, yeah, and then expand the brackets. So that's an alternative way. Right, maybe we'll do it that way. We've done long division, let's do this the other way then. So x to the 4 plus x cubed plus x minus 10. We're multiplying both sides by that divisor, so it's gone from that side. This side we're going to have ax squared plus bx plus c times by that divisor x squared plus 2x minus 3, and then because that last bit gets multiplied by the divisor as well, you're just left with dx plus e. Okay, so now we're going to compare coefficients, and we want to be able to compare coefficients without having to fully expand brackets. At this stage you should be able to do most of that in your head. So let's compare the x to the 4 terms. So on the left hand side, in front of the x to the 4 term, or its coefficient is 1. On the other side, if I multiplied out the brackets, I would get ax to the power 4. So a equals 1, okay? Right, x cubed, let's compare the x cubed terms. Right, so in front of x cubed, on the left hand side is 1. On the right hand side, if I expanded the brackets, let's have a look, I would get, if I multiplied that, that would give me an x cubed term. So I'd have 2a in front of x cubed, 2a. Now I'll also have, when I multiply this bx by this x squared, I'd have bx cubed. So I'll also have plus b. Now nothing else is going to give me an x cubed term. Now I've got this little equation to solve. I already know that a is 1. So if a is 1, I've got 1 equals 2 plus b, which means b equals negative 1. Okay, so we've done that. Next one, let's look at the x squared terms. We could do that if we want to, x squared. So in front of x squared on the left hand side is 0. There's no x squared over there, so it's a 0. And on the right hand side, if I multiplied this out, I would get negative 3ax squared. Then I would get 2bx squared, and I'd also get cx squared. Okay, right, so I already know that a is 1. I know b is minus 1. Okay, what does that mean? That means c equals 5. Right, we're now on to d and e. Now if you look at d and e, d has only got x in front of it, so let's compare the x terms now. So if I compare, the x term on the left hand side is just 1. On the right hand side, I would, in terms of x terms, I would have minus, let's show you here, that bx times by minus 3 would give me minus 3x. So I would have minus 3bx, sorry, so that times that give me minus 3bx. So minus 3b is an x term. Another x term I would get by doing this c here times by the 2x. I'd have 2cx, so I'd have plus 2c. Then I would have, there's the only other x term there, d, so plus d. Those would all be the coefficients of the x terms. Right, b is negative 1, c is 5. We want to find d, so we'll take away 13 from both sides. So that means d equals negative 12. And then last of all, we'll look at the number terms. And on the left hand side, I have negative 10. Now what am I going to get for number terms? On the right hand side, well, I'll have minus 3c or negative 3c and e. They're the only things that are going to give me number terms. Plus e. C I've worked out, so negative 10. C is 5, so minus 15 plus e. So that means that e equals 5. If I'm right, negative 15 plus 5, yeah. Right, so my final answer can be written like this. 1 x squared, because a is 1. So x squared minus bx minus b is negative 1, so minus x, plus c is 5, plus 5, plus, now what's the remainder? Well, it was minus 12x plus 5. We might want to write 5 minus 12x over the divisor, x squared plus 2x minus 3. So that's the other way of doing it. So there we compared coefficients. No long division required. Right, so you should now be in a position where you can do exercise 1F on pages 16 and 17.